Welcome, everybody. Tonight we're going to be working on Unit 2, and this is where we learn some of our most fundamental SQL coding skills. And just a reminder for anybody that's watching the video, we are working with MySQL, which is a freeware version of the Oracle database system. And it does have some special syntax that is unique unto itself. Um, we do not use a textbook in this course any longer. And so we're using a lot of online resources to kind of augment our learning. However, from time to time, you'll find like things like remnant features of our old textbook sitting in the course shell here, like the PowerPoints, for example, are still there. And I don't intend to remove them for the most part, unless they don't match the material. As long as they match the material, I'll keep them there. I do as a matter of habit, at the top of each unit folder that we're working on, I like to list the main topics of what we're going through. These are undergoing revision right now because of our switch away from a textbook. So I'm trying to remove all the language that would say, hey, read chapter 5 or something like that. I'm changing all of those resources to online ones. So like some of the things that we will be learning today, you see in the topic list here. And you see that I have them all linked up. And granted, all the W3 schools link basically go to the same site. So it's a little bit redundant, but if you wanted to go to one of those topics directly, these are the main topics that we're going to be talking about this evening. We'll also take a look at the MySQL tutorial site. And in fact, why don't we just dive into these sites right now? I'll give you a little bit of like micro lecture on some of these topics as we're moving forward. And then I'll continue down the unit folder here, item at a time, explaining all the content until we work our way down to the assignment. And then time permitting, we'll try to get a start on the assignment. And with any luck, hopefully we'll get it finished right here in the class session. And then really all you have to do ultimately is code along to make it all successful. All right, well, let's transport ourselves over to the W3 school site. And I'm just going to open up the main site here in a tab. And the little bit of history I want to give you about this, and I know I gave you some last week too. W3 Schools is a website from the W3 organization. And many of you will be like, well, why is that important to me? W3 as an acronym is WWW, right? And it's the World Wide Web Consortium that puts together this website with all these reference materials. The World Wide Web Consortium is the standards issuing body for the internet. So when they decide to change the fundamental languages of the internet, which happen to be the first 3 listed here on the tabs, HTML, CSS, and JavaScript. And if you guys are a web student, and I don't think I have any in this particular group here, or maybe one, those are the 3 primary technologies of the web, right? Like just about every web page has those 3 technologies. Since the W3 writes the standards for those languages, what better place to go learn about those 3 languages than their official website? They explain how all the HTML, CSS, and JavaScript code works and how it should work according to the current standard. And so on those 3 languages, this is the preeminent site on the internet for anybody to reference, any web professional. But as we learn how to code for the web, and even if you guys are data analytics students, right, you don't worry about those 3 languages generally. But as you learn to code and create applications, you start to realize that there's different types of code. The one type that we're looking at here, so these are what we call markup languages. That's why you have an ML in it. This is a kind of a structural language. This is a styling language, and this is a programming language. And as we kind of move across, you'll notice a SQL, which is for writing database code. You'll notice a MySQL one way over there. Python, another language that most of our students learn here. Java, another popular language. PHP, another popular language. And often when you start to learn that you can attach databases to websites and applications or to store information, you start to learn about these things. And then you start to learn that you can take regular programming languages, and these 3 are programming languages, JavaScript is as well, and write computer code to drive the back end of a a web application or a standard application, and then that application can talk to a database. And what you're going to start to get is what we call a development stack, right? So whenever you hear this terminology thrown around in technology circles, they'll say like, what stack are you working on? And what that means is like, what combination of technologies are you using to build what you're building? You know, and that will vary from project to project. When we're working on websites, very commonly we learn how to write SQL code, but we use the MySQL database system to drive the back end of a website, regardless of what programming language you use, whether it's JavaScript, Python, Java, PHP, C sharp, or whatever. And I say whatever because really you can use just about anything as long as your server's set up correctly. But in terms of the popular usage in the application development space, MySQL is king when it comes to the internet and internet-based applications. And a lot of people go to it because basically it's free, you know, and it works really well and it's very robust. So my hope is that you will come to this page often, maybe bookmark it, and start reading through this. So they start talking about what MySQL is, right? And you know, we looked at this stuff last week, if you guys remember, right? So like, what is it? So here's some information about it. So you can see it was developed and first released in 1995, right around the same time the internet just really started to take off, which is one of the reasons why it was so popular. Who uses it? Here's some really big website systems that use MySQL. Yeah, Facebook is run on top of MySQL, which is pretty fascinating. So that's kind of a mind blower right there. It is the back end for a lot of content management systems, and really a lot of databases that we interface, especially through the internet, will have that on the back end. You know, so they have a little example here where they start talking about if you are going to build a website, right? Okay, so this assumes that you're building a website, but it could just be an application that shows data from a database. It shows you what tools you will need, for example. Now, what tools you need to work with a certain database will depend, right? So like usually we think of the database itself as separate from the software that manipulates it. And this is a really big concept that a lot of intro database people don't really latch onto right away. So I'm going to hammer it a little bit, right? So when they say here, like if you want to build a website that shows data, you know, yeah, you got to have HTML and CSS, you got to know the SQL code, and you have to have some sort of programming language on the server that will run it all. But ultimately, you need to have an RDMS database program available. And they say MySQL, and I think this is a little bit deceiving. This is why I'm focusing on this a little bit. There's a combination between the technologies, right? There's a server component to MySQL that runs basically quietly in the background of your system. And then there is a software component that allows you to interface with it, which we typically call the RDBMS, right? And I want you to notice that the relational database management system that we're using is MySQL Workbench, right? And it's just a program that's used to maintain the database. That's what it is, right? So they're discrete components, and just kind of keep that in mind. All right, so we talked about some of these concepts too, like what is a database table? And then we talked about how there's this correlation between what we call tabular data that you find in spreadsheets, and then the tabular data that creates database tables inside of a database. And a database is usually a collection of those tables. The tables usually, you know, when we say tabular, that means rows and columns. The columns are named, the rows contain individual entries of information. And, you know, typically the way I think of it, mostly because I was taught this way, is that when we have all these column headers, right, and you can see the column headers that they're using here, every time you have a record, it's in a row, and each individual row is representative of one individual entity or occurrence or item or subject or whatever. So the data in that row relates to all the other things in that row. It does not relate to customer two or customer three, right? And it's all in the row together because it's part of the same entity, right? So these are kind of, fundamental but important concepts. When we start to look at the concepts of a relational database, we will have collections of tables that hold information. The relation is how we tie the tables together. And the reason we tie tables together in the first place is to create an efficiency in the information structure so that we're not storing more stuff than we need to. So, for example, if one of my customers here in my customers table, let's say, puts their information in here, their demographics or whatever, name, address, phone number, email, whatever. That's essentially what this stuff is. Every time I process an order from this customer, I don't need to repeat the information. I can find it in the customer table, right? There's no need to regurgitate it again. So it saves us a bunch of storage space. So that customer might place orders, and in the orders table, we might not be including any of the information aside from their customer ID. That's the only piece that connects this order to this person. But that relationship between this customer ID and that customer ID is kind of the essence of what relational databases are all about. This is the efficiency. So instead of repeating, okay, well, this is customer 5, instead of repeating all that information here with a bunch more columns and data, we just say 5, and then it looks it up at this table, and you have the information. That's kind of the thinking. Now, any of the other columns in here could also relate to other tables. So, for example, if this customer places an order, apparently this employee took the order, so there's a separate table for employees. They placed the order. This is the order ID, and this is the shipper ID. So we know from this table that if I look up the shipper ID in my shippers table, I can see that we're using this shipper to ship the product out. Once again, this information does not need to be redundantly stored in this table. And this is the essence of the relational database system and what we mean. So when we're working inside of MySQL Workbench, you will be able to look at all the tables, and you can even generate graphics that show how they connect, those types of things, which is pretty cool. The language that we're about to start working with is called SQL or SQL, and once again, I think I informed you guys that there's kind of like in the IT world, there's people that will have big old fights about what the proper naming convention is. You choose what's comfortable for you. I tend to say SQL, but every once in a while I say SQL. It doesn't really matter. I mean the same thing, but just make sure that you understand that. The cool thing about learning SQL is it is pretty standardized. I did mention that there are some nuances in moving between different vendors' databases, but most of the major database systems do support the SQL language in pretty much identically, not absolutely identically, but pretty much. There's nuances. Once again, some database systems have features, for examples, that others don't. So you can't write a command for something in MySQL that only works in Microsoft SQL Server. That would be a great example. All right. So the general point of using the query language, though, is, and you'll notice what they say here, to insert, search, update, and delete database records, right? That's the general intent of it, but it can also be used to build a database, or to connect a database, or to secure a database. There's all these different things that you can do with it as well, but those are the primary functions. Now, whenever you're working on W3 schools, and I didn't really demonstrate this last time, you will often look at reference materials. And whenever you get into one of these example boxes and you see a green button that says try it yourself, you can do exactly what it says. And what it does is it brings up a in-browser coding environment. I'm noticing that they changed the layout of it. So last time I looked at it, this was a left and right thing. But I think what they've done here, because this is a SQL table or a database that you're attaching to, you do have the ability here to look at all the different tables of data and notice how many records or rows of information are in each table. So, for example, if I click on customers here, it should show me the customer table. And then I want you to notice what happened. As I clicked it, it actually wrote a SQL statement. And the SQL statement, and two of the key terms we're going to learn here today are select, which is almost always the start of a query, right? And I say almost, not always, but typically. Then we have a little phrase here. What are we selecting? And in this case, we see an asterisk. All right, an asterisk is considered a wild card, which means select everything from where? From the customers table. And then notice that customers is spelled ideally exactly as the table is named. Now, there is this little thing that you'll notice in the syntax here. The syntax for SQL commands that are native to the language, the convention, and this goes way, way, way back, we're talking like decades, is to write all the SQL code words or keywords in all caps, right? A lot of people who already know how to code in SQL, um, you know, insist, that it's got to be all caps. You're not doing it right. It's not all caps. And here's what I'm going to tell you. Most of the time I'm typing SQL commands these days, they're all lowercase. I just don't like mess around with even like holding down the shift key or caps lock or whatever. So that's kind of on you. If you want to do all caps and stick with a convention, and I want you to understand that the difference between the word convention and rule. Convention is what everybody does because everybody else does it, not because it's necessarily the only way. A rule would be that you're not using the right keyword. So instead of from, I said to. That doesn't make sense in this context. So be mindful of those things. When you do make an error in the code, and when you're using an IDE like MySQL Workbench, things that are incorrectly spelled will underline so you can fix them, so you know that they're wrong. The other thing that will happen in the MySQL Workbench environment is it will also IntelliSense, meaning it will read the potential of what code works based upon what you're typing and then help you auto-complete it if you so choose, right? We'll see how that works when we get into the product. But for right now, I could look at any of these tables. And I just want to show you, like if I look at, let's say, the employees table, you notice how the code switched, right? And I'm looking at all the contents of the employee table here, right? I can do nuances to the commands, but basically even learning this fundamental command is a pretty important one. It's the select what, basically, from which table, right? In this case, once again, the asterisk is a wild card. We just want to see all of it. So this is a useful command if you just want to look inside of a table and you don't have a graphical tool, right? So this is really pretty helpful. All right, I'm going to go ahead and close this tab, but just be mindful of the fact that whenever you see these buttons, you can run a sample database right here in the browser, play with the commands, see how they work, or if maybe you're stuck on your homework and you're not sure how to do something, you can look at the examples here or work through examples to help you kind of, knock loose in your brain or learn in your brain what the correct approach is. Notice that they point out the case sensitivity here, right? SQL keywords are not case sensitive, right? The convention is all caps, not the rule, right? So this is a convention. They do mention that they will use all caps, and I'm going to guess probably because whoever developed this was more comfortable with that, right? And also because it tends to be the standard. As we do write any SQL statement, one complete SQL statement, when it's completed, will have a semicolon at the end of it. That doesn't mean it's necessarily on the same line that you started typing on, right? So this is a pretty critical thing. Now, if I go back to this little try it yourself thing, just to show you, there is a semicolon at the end of this line. Now, if I remove it, I'm going to speculate that if I hit the run engine, it will still run it. Let's just try, right? All right, it still worked, right? But if I had a separate statement that followed, it would not know what to do, and it wouldn't know where the first statement ended and the next one starts. So if I have a discrete statement, so for example, if I tell it to select this table and select that table, and I don't have a semicolon here, that's one of the things that will often catch you when you first start on this. You know what? It still burns me every once in a while, too. So it's very easy to forget the semicolon at the end of a line. And just to be really clear, and I'm going to zoom in here just a little bit, this is a semicolon. It's a period stacked on top of a comma. This is a colon, right? That's not the same thing. Those are two different things. The semicolon terminating a line of code is pretty standard in most what we call C style languages. So, like if you were learning how to code in Java, for example, every time we write a statement like print line, hello world, that kind of thing, you would put a semicolon at the end. And if you don't, the Java compiler screams at you. MySQL is a little bit more forgiving in some circumstances, and you just saw an example, it might still run, right? But if you have more than one statement, then you got issues. So you can actually write select statements that are 10 lines long, and the semicolon doesn't come until the very end of the statement. And the reason we do that is because it's easier to look at the code by separating it over several lines. You'll see that as we kind of press forward here. So, all right. Some of the most important SQL commands, and I think this is kind of a nice little list here, and we're going to be working on some of these here today. You'll notice that some of these are structural commands and some of these are functional commands for the data. And where we start is we start manipulating or extracting data that already is present. You know, we're not super worried about creating the data at this point. We're more worried about extracting the data. But you'll notice that the first few commands here, and you know, these will come later. You know, by the way, we're not going to really focus on those here today. But the select statement is the one that pulls the data from a database. Arguably the most useful query command. Like, what good is data in a database if you can't pull it out? All right. There is an update and delete command. And then there's an insert into, which is to add into a database. And here we, you know, and I want to be really clear here. The first four commands say that, you know, inserts new data in, you know, from a database to a database, new database, you know, whatever, all that stuff. Really what they're saying is a table in a database, not necessarily the whole database. Right? So I think that that's an important distinction. You'll also notice that there are ways to take a database structure like the core database and create it from scratch, or adjust that database, and ultimately there's a way to also delete a database too. And if you're curious, the command is drop database, but that can completely destroy your database. And by the way, if you ever do something like that, there's no undo with SQL commands, right? There's no Control Z when you do this stuff. If you are altering the core database, so you destroy the data, that data is gone, right? There's no undelete, there's no trash can, there's no Control Z. So I just want you guys to be really clear about that. So what I often recommend when you're working with this kind of stuff is be careful with your steps, you know, and just remember that there's always a way to recover. And usually the recover is to rebuild the database or reload the database, right? So just be mindful of that. There are some other commands here too that are related to tables, right? So you can see that you can create tables, change tables, get rid of tables. And then we have other things called indexes or indices, actually, when you say it plural, that allow you to organize the information in your tables so that you can find it quicker, sort it, etc. All right, so those are the most popular commands. And then where we will end up first, and I think some of the key commands that we're focusing on this week, one of them is the select statement, and we just kind of played with it a little bit, but this is the first, let's say, real content page here relative to this stuff on W3, right? Like, okay, well, get me to a command, let's start coding, right? This is the first thing. And select always comes first. Why? Because we want to get that data out of the database table, right? So it says here, the select statement is used to select data from a database. The data returned is stored in the result table. So that's called a result set. So now here's kind of an interesting concept. When I query a database for information, what it returns to me is a table. So I'm querying a table and I get back a table. That's my result set. So all the information that you're pulling comes from a tabular setup, and then all the results of the queries I'm writing also end up in a tabular setup, right? So this is the general structure of a database, remember, is that tabular structure. Now, the select syntax, and here's where we kind of get used to how they present the information to us on this website. And I'm going to see if I can zoom in a little bit just to maybe get rid of the ads. And maybe I should be using my ad blocking browser here, but I guess I'm not. So the general form of a select statement starts with the keyword select, and then notice that they have a comma separated list of which column. So you don't have to use an asterisk. An asterisk is a wild card, it means it'll grab all the columns. But if I want to look at my customer table and I only want to look at the last name and the city or something like weird like that, I can specify which columns where we want to come back in the query, right? So that is very helpful. I don't need to look at their address. I just want their phone number, that type of thing. And then the from keyword's important too. And the from just simply indicates which table we're working with. And the table name needs to match one that actually exists. Notice that they're separating the select statement on one line, and I will be careful about how I say it, the select portion of the statement on one line. And by the way, and we should always say this in a coding class, whenever you see like in coding examples, somebody goes ... that always stands for and the rest of it. What is the rest of it? I don't know. This is kind of imaginary. You know, if I have a table with 100 columns, I might be selecting 40 of them, right? So I might be listing column 39, column 40, etc. And by the way, typically your columns won't be named column 1, column 2. It'll be like customer ID, first name, address, whatever, that type of thing. So it's not unusual when you write your select statements to do like what you're selecting on one line, which table you're selecting from on another line, and then your semicolon. But because the semicolon is on the second line, doesn't mean it's not the same statement. This is all still the same statement. Right? This is the takeaway. All right, so we kind of already saw an example of this, right? So the wildcard allows you to select all the columns. And once again, they have their little demo database here that they use pretty much throughout. Now, we've done the select all the columns. We saw how that works. But here's an example of looking at the customer table again, but this time we're just selecting the customer name, the city, and the country from the customer's table. And so let's click on the Try It Now editor and bring that up. Of course, if you want to look at what the customer table looks like, you can just click the title here. It writes the generic asterisk driven show me all the columns approach and then runs the query. This will only extract the columns that we are looking for, and you need to be precise with the naming here. What you will notice, a lot of times column names for columns in database tables are named in this fashion where we'll start with a capital letter and the next logical word inside of the column name starts with a capital letter. This is a convention, once again, that database people use. Another convention that database people use often is sometimes they'll put underscores in between logical words. So you'll see a mix. There's no rule, once again, as to how you must name it. The one rule is, though, that a column name can't have a space in it, right? So don't tell yourself that you can name it whatever you want. There are rules here, just like naming variables in a regular programming language. Generally, this approach we call camel casing, where the words in the middle are also, there's more than one word, capitalized. All right, I'm going to go ahead and run this, and I hope you guys have done this already, but it's going to go into that table that we looked at before, and it's only extracting those columns and all the customers that are here. And you can see this is pretty international company here. They got people from all over the planet, different languages, different countries. So pretty cool list. And you see like how much information, there's 91 customers in here, right? So there's 91 if you count them. But it only gives you those 3 columns of information. Right. So if your boss said, "Hey, give me a list of all our customers and what country they're from," you know, uh, this is what you would give them. They don't care about their email address, what order they placed, um, what their customer ID number is. They don't care about any of that. They just want to see a list of the customers. Maybe they recognize the name. Right. But remember, the return result is a table from the query. All right. We did the specific columns. We've already done an example of selecting all the columns. We saw how that worked. Now, this is something I'll mention here, and this is not really required for the work that we're doing. But this is a special command too that's out there for MySQL. And it's, read what it says here. It says the select distinct statement is used to return only distinct different values. So in other words, if I'm, let's say pulling back the first names of all my customers, right? I would only pull them back if their name is distinct, and so in other words, this is a way to kind of omit duplicate values. So sometimes in database tables, this happens where, let's say the same customer places 5 orders, right? I don't need to see his name 5 times. That's kind of the thinking on this. Not something we're using initially, but just be mindful of that can remove values. So let's just look at the really quick example. So if they select just the country from customers, this is a really good example. So we run that, and then we have 91 records. So every person is listed here, and some of the countries repeat. Okay, because I have more than one customer in Venezuela, for example. Now, if I run it with the distinct statement, this is a good example, right? Because the boss just wants to see what countries our customers are from, not how many from each country, just what countries, right? So here's the list of all just the countries that are unique. So it goes from 91 down to 21. We have 21 unique countries where our customers are located. So that's the usage of the distinct statement. Now, there's this other function, and we'll talk about this, right? Where we can wrap what we call a function, and count is a function, right? And formally, we're not really covering it today, but this is a helpful one, so it's not a bad time to talk about it. But you notice how we're basically building our regular select statement, adding the distinct to it, but as it runs, we're running a function on top of it. So this is basically wrapping code inside a code. And what it'll do is it'll count how many unique countries we have. All right, let's just run this so you see like the output. And notice what it's going to do. It's not going to list the countries now. It's like, how many different countries do we have customers in? 21. That's what it's telling you. It's just giving you a count. How useful this is relative to whatever your task is. But if you wanted to know that information, like how many countries on the planet do we have customers in? Well, 21. I don't care about, which countries. I just want to know how many, you know. Um, and the previous approach, we got to see all the countries. We also saw the number of records at the top, so the count becomes a little bit superfluous. But if you're working on a really super large list, sometimes it's easier to run stuff like this to get a count rather than run a different query and then look at the results and count how many rows came back, because that's basically what happened on the screen. All right, so that is um, the overview of the select statement. And then the other thing I want to point out on this website, which is kind of neat, right, is they have this little kind of like on the fly quiz thing that if you want to test your skills and whatever, it says drag and drop the correct parts to form a legal SQL statement. All right. So from what we've learned so far, I'm going to do select star from customers and submit the answer. And then you can see if you did all right. Correct. Yay. All right. And what you will notice, and they'll do this all the way through most of their courses, is you can test yourself with each thing. So you can practice a little bit here on the fly. It's not like super fancy or anything, but it's enough, where you can kind of review a little bit of what you just learned. And I think that helps that. Okay, so I have a question in the chat here. Do SQL indexes start at 0? The answer is kind of a combination. Okay, so it depends on what you mean by an index. Let's start there. Like if you're looking at a table, usually the first row is the column headers, right? So that's kind of the 0 row, and then the data starts in row 1. If you're looking at the information in the columns and you're going across a row, the index of the first column is 0. Right. And this isn't super relevant. It's more relevant with data that we're processing than the structure itself, I would say. Right. I'm going to move on to the where statement here. All right. And the where clause is where we use, once again, our basic select statements to pull in information. And we add basically a third term to it to control our statement. So the general syntax is we select which columns or everything from which table, where, and where is our conditional statement. So it's in other words, we're going to set up a condition that's going to qualify what we're pulling back. So like, for example, I might be able to qualify it on which country my customer is in, or that if their order exceeded $500 or something of that nature. It's a condition. They're calling it a filter. You can think of it that way too if you're like spreadsheet minded. But it sets a condition for which we pull back data. The where clause is used in a lot of different statements to set up conditions. And let's get down here and look at the customer table here. So in this example, they're going to pull back all the customers, and then notice the condition is where country, which is a column name, equals Mexico. And I want you to notice that Mexico is inside quotes. Now, albeit these are single quotes, but double quotes are valid as well. There's a little bit of a discussion with SQL programmers who use double quotes or single quotes, and it's the same discussion that regular programmers have too. And the reality is usually in most languages, they're interchangeable, right? And that's to allow for nesting, and that kind of goes down a different rabbit hole. Let's go ahead and just run this really quick so you can see the difference, right? So we're pulling back all the customers with all their details, all the columns, right? That's what that means. Where their country is Mexico. Okay. And that works. Or if we wished, we want to say, I don't know, Spain. We can run that again. And then we see we have 5 customers in Spain. And if I didn't want to look at all their information, for example, I could just say customer name and maybe a city. Okay, so who they are and what city in that country they're from. So we run it again. You'll notice we have it boiled down, right? So this is pretty helpful, right? I mean, because if you're looking for very specific information, you can narrow down with the where clause. It is possible to have compound where clauses too, but for now we're going to focus on one at a time. One is good. All right. Now, one of the issues that we start to contend with when we're building a database, and we're not quite at that point yet, is whenever we have a column in a database table, that column can only hold a very specific type of information. So, for example, for a name, it makes sense for the data type to be text, right? Characters, basically. Characters, possibly with spaces, possibly with numbers included too, or special symbols, but characters. Then we have other types that'll only be numeric. So, for example, if I'm looking for a certain customer ID and there's no quotes around this, right? This is just the number. This is being treated as a number. And when we see a number in a coding language and the number does not have a decimal point after it, we call that an integer, a counting number. And in this case, we would be running this query looking for the customer with the ID of 1. And if I wanted to change that number to something else, and then you'll notice, oh, you put a space in there. Is that going to break it? No, it's not going to break it, right? But I can pull back that particular information. Real frankly, often when I write code, I put spaces on both sides of my equal sign. That's just me. If I change this and I put in quotes, either single or double quotes around this 5, it will now start treating it as text, and it will start looking in a column for it. Now, I want you to see what happened here. It still worked. This is really weird, right? So some of this stuff does work. Some database systems, this would absolutely not work. And in some, like MySQL, it is actually pretty flexible, and sometimes it'll work anyhow. If you know a column is numeric, though, right? And that's kind of what the assumed given is here. You want to ideally send the right data type in, right? But you still get the same result. All right. I'm going to close some of these example tabs here if you guys don't mind. And all right, there's some other considerations with the where clause. And one of the considerations is that we're not looking for a specific piece of information. We're looking for a piece of information that is relative to something else. So we can use operators. So for example, I might be looking for, let's say, a sales amount greater than $100 or greater than or equal to $100, right? And then you can use this terminology here to go through. I want you to notice these are the same operators that we use in mathematics. The ones that might be different are the ones down here. In mathematics, we usually, when we say greater than or equal to, we do it more in a fashion, and I apologize, I did not mean to do that. We do it more in a fashion like this, so we go greater than, and then you just do a single slash under it, and that's greater than or equal to in math. That's not how we do it in coding, though. It has to be written like this. So greater than first equals after, or less than first and equals after. The other one that's a little bit weird in SQL, and by the way, the only other language I can think of that does it this way is Visual Basic, if I remember right, does not equal in this fashion. Most programming languages will do exclamation equals for not equals, but in SQL code, it's like this, like greater than, less than, or less than, greater than put together. They also have some other qualifiers for where statements too that are verbal, and that's what this list is about here. So in other words, that you can be between a certain range or like something, which is what we usually use for searching, by the way, or in something, or once again, part of something. All of these different examples here have little try it editors, and I would encourage you all to go through each one of them and try them all and see what they're about. I'll just give you a couple smatterings really quick. So let's just do one that's less than really quick. So in this example, we'll select everything from the products table where the price is under $30. Now, without having ever looked at the products table, but I want to see all the stuff where the price is under $30. So we'll run the command, and then you'll notice whatever your products are here, and then you see the price in the far column. But everything is under 30. I could change this, right? So right here, I could just say greater than or equal to, I don't know, $130. I don't know if I even have any products like that, or one product, that's greater than or equal to 130. But you see how you can change that very dynamically. So you can find very specific items. The other ones that get kind of interesting, like real frankly, like the between command, that's kind of an interesting one. And notice how you use it, right? So you say where the price is between 50 and 60. We're very conversational in its coding syntax, so to speak. So if you run the query on that, you'll see stuff that comes back that does fit in between. Between does not include those values, though. So something that's exactly 50 won't be there, and something that's exactly 60 won't be there. 50 and 1 cent or 59.99 would fit, but not 60 or 50. Let's see how that works. The other one kind of useful is like, and this is one where we will actually start doing searches like this. Now, this is really weird because this is text and it's searching for a city where it's like S percent. What the heck does that mean? Now, when we get inside of a string, a percent sign is the wild card or character for doing searches like this. So every city basically that starts with the letter S would come back in this query. And I want you to notice all the cities all start with S, right? And this is a like command. If I wanted to, let's say find this particular city here, I could actually come in here and do that, right? And then it'll find exactly that, right? But that's kind of like our search. Like is our search command in essence. In is another kind of weird one. This one basically allows us to have a range of values to search from. So if we're looking for either customers from Paris or London, you see how I'm saying that, right? We have a list of the cities they could be from. So if the city that customer is from is in my list that I have here in between parentheses, that will return them as well. So those are all kind of pretty nifty and handy. So my London customers, and if I scroll, I see my Paris customers too. And of course, add different cities or change them, or use any of that syntax that we've used so far to help narrow it down. The last command that I want to look at here is, or last couple, are order by and limit. And as soon as we're done looking at those, we will take a break coming up here if you guys are wondering. So let's go to order by. And this is kind of an interesting little tool because it allows us to take the output of the information that we're retrieving and then sort it in its output. So we come back with a table. Well, how about that table comes back sorted? Wouldn't that be helpful, right? So general form is the select which columns from which table, and then we order by, and then we say by column 1, by column 2, and then optionally you can add these keywords for ascending or descending. And you don't have to have multiple columns here. So let's just take a look by example here, where they're going to pull back our customer list and we're going to order by country. So if I run this query, what's going to happen here is all the countries here are going to be ordered alphabetically if I'm looking at this column, right? If I happen to, for example, order by country, comma, I think it's customer ID, it'll first sort by country, then it'll sort by customer ID. So this is the combo of that. So Argentina, and then notice within Argentina, all the customer IDs are in order. Then when we get to Austria, they're in order. When we get to Belgium, they're in order. If I wanted to flip the order of this, If I want to do the countries, but I want them alphabetical. I want them reverse alphabetical. I can use the descend command, right? And then that will run, and the last country will list first. So we start with Venezuela, USA, and then we work our way down to Argentina, right? So that's an example of how those work. Those are pretty simplistic examples. We just kind of did that one. And we kind of did that one too, right? So you can order by multiple columns. This is sometimes very helpful because sometimes when you're running a query and you want to see information, you want to see information that's relevant, right? Or in a order that's helpful for you to do additional work. That's, and what is that driven by? Well, it's driven by need typically. You can, if you were wondering, can I make one ascending and one descending? Yeah, you can totally do that. This is how you would do it. All right, that's the example here. The other command that we're going to look at real quickly is the limit. They're calling it a limit clause. And what this is useful for is when you are dealing with a real large data set. And, like Martin, like when we're going to be talking machine learning later tonight, we're going to be looking at some pretty crazy large data sets. And often when you're processing them, the last thing you want to do is, hey, I don't want to look at 42,000 records. I just want to look at 20, that type of thing. Limit is the tool that we use in SQL to help us figure out or basically control the amount of output that we have. So notice it says here it's useful in large tables with thousands of records. Returning a large number of records can impact performance. If you just want to run a query and see if it's working without running it through all the data, that's what this is useful for. So I have 100,000 records to run and you want me to sort them all? Oh, wait a second. Let's just make sure it works with 20 of them. And so you literally can use that appended after the where statement and establish a limit. So if I just want to return X number of results, I can specify it. So let's just take a really quick look at how you do that. So if I want to select all from the customers table, but I want to limit it to 3, it's just going to pull back the first 3 records. I just want to see if my query is working. Oh yeah, it's working great. Right. So that's an example. Very simplistic one, but sometimes you have that limit. And functionally, when you're working with large data sets, this is a thing that clever database people do, right? I want to see if my query is working. I don't want to run it on 1 million records. Let's just do 100 and see if it's okay. That's the thinking on it. All right. The other one that's kind of interesting. All right. So what if I don't want to select the first 3? What if I want to select the third or the second 3? If that makes sense, you can do that and you can set up an offset. So the offset basically tells it which record to start on. Okay, return only 3 records, start on record 4. So this is an answer to that first question, right? Because if we have rows of data, the actual data rows are numbered starting with 1. So let's start. Offset 3 means we'll skip the first 3 is basically what that means, right? If you combine statements, and this is something you learn how to do, right? This is kind of the art of writing SQL code. You will select all the customers from the customers, or all the columns from the customers table where the country equals Germany, and we'll limit that to 3 and run that. You can also throw in an order by clause. So I can select them, order by country, and limit it to 3 or 30 or whatever. That's your choice. And I'm not going to demo those. I think they're pretty self-explanatory as to what they're going to do. All right. Before we take a break, just very quickly, I do want to talk about this other website called MySQL Tutorials. And I'm actually going to go right to this particular page in here. This is a site that we find really helpful in a lot of different ways. I have one negative comment about it. Once in a while, some of the ads get a little spammy. So if you have pop-up blockers, I'm not running one in this browser right now intentionally. But when I use like Firefox or Brave or one of those, I'm always blocking the ads. Some of the ads in here are pretty obnoxious, and sorry to the people who created the website, but that's the truth of it. And I get it; they got to pay their bills. I think this is a particularly useful page also because it is providing basically the same information that we just looked at in a different format. And what's nice about it, and let's just kind of click into one of these, is you can click in, and for each one of the statements, they have examples. You can copy the code if you wish. They give a little bit more verbose detail about how it actually works, which I think is helpful. And they have an ample amount of examples here. They also provide sample databases, one of which we will pull down and use a little bit later today. But I do provide links to this information, and when I'm providing the links to it, I kind of expecting that you guys will read through this material. Now, even though you can wait to come to class and listen to me talk about it, that's fine. But I think it goes better, and I'm just saying this up front, if you read up on this stuff before you come to the class session, and that way you're ready to roll. And I hopefully don't have to explain as much, and we can get to coding all that much faster. If you have questions about what you read, because right now it's pretty basic, but when it gets more complicated and you have very valid questions, we'll take our time to explain through all of that stuff. All right, why don't we go ahead and take a break? I'm going to pause the video here. We'll come back and we'll finish up the content portion, and then we'll get into working on the exercise. When I start the exercise, I will record a discrete video. For right now, I will pause, we'll mute myself, and I will see you guys in 5 minutes. Okay, welcome back from break, everybody. We are going to be moving through the rest of the material here in the unit folder right now. We just took a look at all the topic materials, basically the lecture portion of the class. I did do some updates here to the course shell, and I'm trying to bring all the content in all my course shells forward so you don't have to click through to go to links to see the content. That includes the video link here. And in fact, the video that I'm recording right now will appear here in this spot, hopefully as soon as tomorrow, provided the rendering is done by then. And, generally, I tell students watch the videos from the current semester first, and always the newest ones. Once again, these all post to YouTube, so you can use all of YouTube's wonderful tools as well. And if you subscribe, you can get notification as soon as they're published. I also have the PowerPoint here from the author if you guys are interested in looking at Murick's MySQL 3rd edition textbook. That's where that PowerPoint comes from. That is what we used to use. And this spring we decided, textbooks are going away for the web program. I think we're only going to have maybe one course or two courses in the whole degree that have a book, which is a huge cost savings. So be thankful for that. Another resource that we have out there, and I know many of you are already aware of this if you're already current students, but if you're not, and some of you are either taking this as an elective and you're not even in an IT program, or you're coming from other schools and taking this, that happens in the summertime pretty often. By virtue of having a Gateway student email account, all of our students have free access to the LinkedIn Learning video instruction platform. LinkedIn Learning, if you're not familiar with it, is an offshoot basically of the LinkedIn professional social media platform, by the way. And one aspect of their website is called LinkedIn Learning, which is their video instruction aspect. If you guys are familiar with the older video platform called lynda.com, and in fact, like if you were ever into IT stuff and you'd like Google, how do I blank, you'd often run into Lynda videos on YouTube. Lynda got bought out by Microsoft, who owns LinkedIn, by the way, if you guys are wondering. So it's all Microsoft. What's really cool about it, though, is if like you click through on the title here, it will take you into the platform. Now, I will say right up front, the first time you go in, it's going to try to authenticate you. When you authenticate, sign in. If it asks you your domain, for example, you want to say gtc.edu, or Gateway Technical College, I forget how they ask it, and then use your Gateway student email account to sign in, and you have free access to not only this course here on MySQL, but also every other course that they have in their platform. And it's huge, right? So if you're into anything IT, anything screen related, graphic arts, coding, AI, machine learning, whatever, there's complete courses here on the content. In some cases, we use this, we think of it as kind of an auxiliary textbook for our courses because the videos are really well created. They're high quality. All of them give you like this little, sidebar catalog of all the different topics in the video course. And the one that we're pointing you to here are, the select ones that are already highlighted. So that's what we're asking you to watch. All the videos here are fully transcripted. So as you're going through the video content, you can see how like the sentences highlight. You can click directly on a sentence and it takes you right to that snippet of video. In many cases, there's also interactive little quizzes at the end of each section that you can take. That's optional, of course. We don't require that. And sometimes there's exercise files that you can download and code along with the author. The material is of very high quality, generally speaking, and this is one of my go-to platforms when I want to brush up on a skill or remember how or whatever. I really like it a lot. I wouldn't add it to my course shell if I didn't think it was relevant or useful. So when you see those here, I do recommend that you click through. What often happens to me when I'm watching these is I'll go in to watch a certain thing, and then I end up watching 5 other things too because I'm like, oh, this is really cool. Oh, that was helpful. Thank you. That kind of thing. So I encourage you to take advantage of that. And obviously, I'm not going to play the videos in class. The one thing that I also like about the platform, and I think I say this about YouTube as well, is aside from the fact that as you're watching, and I'm just going to let this roll right now, you
Statements are
can,
often called queries, and they display data from tables according to the filters and constraints listed in the query.
okay, so you can see like the person's talking. There's also closed captioning you can turn on, and I also am a huge fan of the speed control. So if they're just like pushing content at me, I bump that up a couple notches and absorb it that much faster. But what I think is really useful about these is the video snippets are short. This one on select is only 1 minute and 20 seconds long. So it's really easy to absorb, replay, play again, and everything is here explained in just about every fashion that you can think of. So please watch those when I drop them in to the unit folders, please. The other thing that I am going to point out here, and this is something that we're going to do here in a moment, is we are going to take a look at the sample database. This comes from the My Tutorials or MySQL Tutorials website, by the way. It's one of their databases. So you can see that they have a link here. So I'm actually going to click through this link, talk about it a little bit, and then we'll get into MySQL Workbench, and I will show you how to load that up. And then we can utilize that to do some of our work. Because most of what we're going to do initially, I want you guys to be mindful of this, is extracting information from a database, not creating it, right? Just to get our feet wet. All right. So first thing I'll do is I'm going to click on this box here just to take us over to that website. And I want you to notice that, a lot of the information that I have on our core shell is borrowed from here intentionally. The MySQL sample database is the same one that we're going to be looking at. So don't bother grabbing it from here. Grab it from the links that I provide, by the way. And then they talk about what we call the schema of the database. And the schema, you can think of that as kind of like the framework or the structure of the database. And it tells you, the tables basically that are in the database. So customers, products, product line, order, details, payments, employees, offices, etc. Not too dissimilar from what we were looking at on W3 schools, the same kind of thing, right? They also provide here what they call an entity relationship diagram, which is a kind of a concise graphic that shows all of the tables, their names, all of their uh, column headers, and how the tables connect, right? And right now, the symbology here means nothing to us. Like, what does this mean versus that? Um, and then why do some of these have asterisks and some don't? And just to kind of give you the heads up on that one, when you see in an entity relationship diagram an asterisk next to one of the column headers, that indicates that that's a primary key field, meaning that it has to be unique in that table in order for the table to work correctly. And so if you want to kind of wrap your head around that concept just a little bit, for starters, right, we're not really covering it this week, but the employee table, every employee has a unique employee number. That is how we make them unique in our database. So in other words, you can't have a different employee with the same ID number. Wouldn't make sense. It's possible, and I've seen it happen many times, where there's people that work at a place that have the same last name, the same first name, the same middle name, even the same birth date. I've seen that actually in reality, right? So that seems pretty rare, but it happens more often than you might think. What I think is also kind of neat about these diagrams, right, is it kind of shows you a snapshot of the whole database structure in one graphic. There are ways inside of MySQL Workbench, by the way, to generate graphics like this. And I think that's pretty cool. The connectors here have special meaning. The infinity means many. The slashes means one. And often we have connections between tables that are one to many or many to many, that type of thing. We'll learn about all of that stuff as well. So this is just kind of an example where this information is coming from and where the database originally originated from. What I've done is I've created a link on one of our web servers here on campus to provide access to that database file so that you don't have to go to a third party to get it. I do that for a number of different reasons. Sometimes the third party deletes it or changes it, you know. The other reason is I have control of this server. So if this server's down, I can do something about it. If their server's down, I can't do anything about it. And real frankly, it's a localized database, so we can grab it and use it. This is open source, by the way, so it's nothing like we're stealing or anything like that. It's out there for the taking. What we are going to do here, right? And so as we're looking at this entry, we will download the script file, and this will be part of the exercise, by the way. We'll, as we did last week, we'll run the SQL file. It'll build out the database with the content, and then we'll go through the homework to achieve all the steps listed in the homework one by one, right? There is a link here, you know, that demonstrates how to load the sample database if you want. And just in case like this video is not enough or whatever, you can click that link and read up on it that way. And then once it is loaded up, you can test it by running some really basic commands like what we've already learned. And then we are ready basically to do the homework. So what I'd like to do for starters is I do want to end this lecture video, if you will, and then we'll turn our attention then to the this activity here, and we'll do this as part of the next video, by the way, and then we'll work on the homework. So this video will end here, and we'll call that a lecture.